Hi friends, it's Miss Etheridge. I want to talk to you today about repeating decimals. So we're going to take some notes in our journal. We're going to look at some different examples. So if you will label this number 12, repeating decimals, and this is September 29th, 2020. If you will put that on your table of topics. And then if you will turn to the next clean page. I've already got this a little bit. I worked a little bit ahead of you. Number 12, repeating decimals. It's going in right behind your examples of your real number system. Remember we talked last week about repeating decimals are real numbers. Repeating decimals are rational. So we're going to go a little deeper into those today. Okay? All right, now remember as you go through the video, when you're taking notes, if you need to catch up, if I get a little too far ahead of you, just pause the video, but you need to make sure you get all the notes in the journal. All right, so when we first start, we're going to look at the ones that it says all digits are repeating. So this is going to be like 2.4444, you know, on and on. The 4 is going to be the digit that repeats. We're talking about the decimal place. Okay? So all the digits are repeating. So let's look at the math first, because I'm going to show you the math of why this works, and then I'm going to show you a shortcut. All right, so the math behind it. Let's say that we have x equals 0.7 repeating. So that means I just have 7s after the decimal, never ending. Okay? All right, so now remember, x is 7/10 repeating. So when I'm working with this, to get it written as a fraction, the first thing I'm going to want to do is I'm going to multiply each side by the place value that this number is. So this is a tenths place, so I'm multiplying each side by 10. Okay, we've got to keep it balanced. Remember, it's an equation. So once I do that, I end up with 10x equals 7 and I still have all of those 7s hanging out afterwards, but this is giving me a number in the ones place that I can work with. Okay? Now, after this point, we're just kind of solving our equation. So almost. So if I got 10x equals 7.7 repeating, remember way back here we said that x equals 0.7 repeating. So what I want to do, because I really need this 10 to come down to a 9, okay? Because this wasn't just 7/10, it was 7/10 repeating. So I can't really work with just the 10. So I'm going to subtract x from this side and 0.7 repeated from this side. Because remember, we said x equals 7/10 repeating. So if I subtract that, that's subtracting the same thing from both sides. Subtracting this takes care of the repeating. And I'm down to 9x equals 7. All of the repeating went away. Okay, that was why I wanted to subtract that off. All right, so now I have 9x equals 7. To solve this, remember this is multiplying, so we do the opposite, which is dividing. So I divide by 9. And I want it as a fraction. That's my whole purpose, is to write a repeating decimal as a fraction. So I don't want this as a decimal. I already have it as a decimal. I just need that fraction. So my answer is 7/9. Okay? So that's the math behind it. Now, I want to show you the shortcut, which you will use a lot more. All right, so here's our shortcut. If all, and that's very important that it's all, not just 1 or 2, but all the digits behind the decimal, if all digits are repeating, you are going to keep the repeating digits as the numerator, because remember we're making a fraction, so the numerator is your top number, and place the amount of digits digits repeating, sorry. Let me put that in, repeating. With 9s in the denominator. Remember, that's the bottom number. So let me show you what that looks like. Okay, pause that if you need a minute to catch up, to get that copied. I know that was a little fast. So if I have 0.4 repeating, I have 4 tenths repeating. 4 is what's repeating, so I just put 4 over 9. I can't put 4 over 10. 4 over 10 is 4 tenths. This is not 0.40. This is 0.4444. It's like having 40 cents or 44 cents. The difference matters. Okay? All right. If I had 2 digits repeating, 3,700 repeating, 2 digits are repeating, so I put 2 9s on the bottom. Now, I could go through the process just like we did up here, and I would come out to this same answer. So this is your shortcut, but you can look back and see why it works. All right, if I had, let's say, 4 numbers repeating, okay, 0.6254 all repeating, guess what? I'm going to put 4 9s on the bottom. And now some of these may reduce, but if we can get to this point, we're okay with that. We're not really working on the reducing part, the simplifying of fractions. We're just getting it set up as a fraction. Okay? So that's pretty basic. That's how it works. Even if we had a mixed number, let me put that in there. If we had 2, and let's say, oh, I just about gave you the answer, sorry. Let's say I have 2 3/10 repeating. So I would have 2 as my whole, or as my base, my whole number, but it's going to be a mix, so it's there. So 3 9ths. Now, 3 9ths reduces, I can do that without much trouble. 3 and 9 reduce down to 1/3, so that's really 2 1/3. So if it's got a number in the 1 spot, you just keep that and then replace the decimal portion with your fraction. Okay? All right, now I'm going to turn the page just so I have plenty of room to write. Okay, now let's talk about if not all digits repeat. This is when we have to work a little harder to find our answer. There's not really a shortcut for this. All right, so let's say I've got 0.32 repeating. So I got 32 hundredths, but only the 2 is repeating. Okay. All right, now I'm going to write this out, and then we're going to talk about what this means. So I'm going to draw a line. This is like the fraction bar in our fraction. Okay. So on top, the number, or the numbers, not repeating, or you're going to have the number minus the numbers not repeating. That's what's going to go on top. I'll show you what that means. And then on the bottom of that fraction, we're going to place 9s for the numbers repeating, and 0s for the numbers not repeating. Okay. So this is what's on top. We're going to take our number, we're going to minus out the number or numbers that are not repeating, and then on the bottom we're going to place 9s for the numbers repeating and 0s for the numbers not repeating. Okay. All right, so let's take that 32 hundredths repeating. Remember, only the 2 is repeating. So on top, we said the number, so the 32, minus the number or numbers not repeating. Well, the 3 is what is not repeating, so I'm going to subtract that. We don't worry about any decimals and none of that. And then on the bottom, we're putting a 9 for the numbers repeating. I had 1 number repeating. and I had one number not repeating. So I'm putting a 90 on the bottom. And then I'm just going to do the math. So 32 minus 23 is 29 over 90. That would be my fraction for 32 hundredths and only the two repeating. So I took the number, the 32, I took away the number that did not repeat. That's where 29 came from. On the bottom, I put a 9 for the digit that repeated and a 0 for the digit that did not. And that would be my answer. Okay. All right, let's do a little bit bigger number. Let's say I've got 0.475, so 475 thousandths, and only the 5 is repeating. Okay. So this time, on top, my number is 475. I have to take away what is not repeating. The 47 does not repeat, so I'm subtracting that. On the bottom, I give a 9 for every number that repeats. There's only one. And I give zeros for every number that does not. So that's 2 zeros. And then just subtract. So 475 minus 47 is 428 over 900. And that one will reduce by 4. That actually reduces down to 107 over 225. All right, let's do another one. Let's do an even bigger number. Let's say I've got 8, 9, 3, 4, 5. Only the 5 repeats. Okay. So let's do the number that doesn't, or the whole thing, I'm sorry, 8, 9, 3, 4, 5, minus the part that does not repeat, so 8,934. So yeah, they're big numbers, but we can do it. And then on the bottom, a 9 for the one that repeats, and zeros for the ones that don't. So I actually have to have 4 zeros on the bottom. Okay. All right, when we subtract 89,345 minus 8,934, I'll just tell you, we're just getting our numbers down here, 80,411, well, there's really no comma there because we're doing a fraction, over the 90,000. Okay. So pretty big number, but we're not worrying about reducing that. We're just going to leave that. Okay. All right, and then let's do one more. Let's do 0.416. 6 is repeating. So we take the whole number, subtract what doesn't repeat, and we're putting on the bottom a 9 for the one that repeats, zeros for the ones that don't. Okay. 416 minus 41 is 375. 900ths on the bottom. Now, I could reduce this. We can reduce on down. Let's go, I believe it reduces all the way down to 512. So I could kind of walk you through that, but honestly, we're not really working on reducing the fractions today. I'm more worried about this process where you can set them up. Okay. All right, and then also I want to bring to your attention, this is also in your textbook. On page 23 is another example. They use the 3/10 repeating. They show you the multiplying by 10 on each side, and they go through that whole process to come up with the 1/3. And then they show you down here a bigger digit of the 512 with that. Okay, so that's also in your book on page 23 if you needed to look at that. All right, guys, that's all I'm going to do for your journal today. Just be sure to check in Google Classroom to see if there's anything else that you need to do. Thanks a lot.